Hi guys, having looked at sets and set theory in the other video, we are now ready to start looking at the application of set and set theory. One of them is a probability. It's used in probability. So we are looking at the probability part 1 in this presentation. What is probability? Probability can be described as the chance that an event E has occurred, is occurring, or will occur. So this idea or concept happens to assign probability values to events, and it is expressed in form of percentages. It can be expressed in form of a decimal, or indeed in terms of a fractional form. So we're going to look at basic properties of probability, and looking at this particular area, we want to be comfortable with certain terminologies that will be confronted with in dealing with probabilities. One of them is a term called trial. Whenever you hear of trial, what should come to your mind is that a trial is an experiment or repetition. A trial is an experiment or repetition. The second one is the term outcome. Outcome in this case implies possible results of each trial or repetition. For instance, if you are tossing a fair coin, the possible outcomes are two. It can either be a head or a tail. It can either be a head or a tail. And for this fair coin, the chance that a head or a tail turns up is said to be equally likely. Okay? The chance is equally likely. Because of it being equally likely, it is called equiprobable. It is equiprobable. For here, we have a probability of a head is 1 out of the possible 2, which is half. Probability of a tail is also 1 out of a possibility of 2. So there are 2 possible outcomes, head and tail. So the chance that you pick, it turns out to be head, is 1 out of those 2. The other one is what we call sample space. A sample space. When you hear of a sample space, what should come to your mind is that this is taken to be a set of all possible outcomes of an experiment or repetition. For a coin, in the case of the coin, the sample space denoted by the letter S is head and tail. These are the possible outcomes when you toss a fair coin. You either have a head or tail. So this is the sample space. We look at the other term, which is in this case is termed as event. When you hear of the term event as it relates to probability, this is simply a subset of a possible outcome selected from a sample space. Okay? So sample space under a specified condition or conditions describing the outcomes to be included, such as or such that probability event E is equal to the number of elements of E out of number of elements of a sample space. So that's how we define the probability of event E. This can also be stated as number of favorable outcomes over the total number of possible outcomes. So that's the basic principle that we follow when you are looking at how do you express a probability of an event. Okay, it's also important to take note that the probability of an event is such that it is between a range of 0 to 1. So probability is such that 0 is less than the event E, which is also less than the event which is less than 1. 0 is less than the event E, which is less than or equal to 1. 0 is less than or equal to event E, less than or equal to 1. So that's what it means. So it means that the 0 and 1, which is known, in between is a matter of chance. So hence we talk about the probability. It should also be noted further to say, 1, an event should be a basic unit to which the probability value is assigned. Okay. Furthermore, we can take it that event is selected only after the sample space has been identified or specified, implying that the event is picked from a given sample space outcomes. Sample space of outcomes. This makes a lot of sense because you first need to look at your catchment area and see what elements are in that particular catchment area, and then you define what you want to pick, or what are the chances that you pick something or some elements which answer your description out of the possible outcomes in the sample space. Therefore, in the third point, we are talking about an event is certain to occur. If an event is certain to occur, then we take that event is of probability 1. On the other hand, if an event is certain not to occur, then its probability is 0. Now, probability 1 and probability 0 are what are referred to as absolute probabilities. Let's look at an example. In this case, I'm talking about a die. Okay, the die is one which is used maybe in playing games. It has a certain number of possible faces. There's a face with 1, another face with 2 dots, another face with 3 dots, all the way up to the face with 6 dots. So that's how it is. So if you are talking about the outcomes in terms of number of dots, then we can say the sample space is 1 all the way through to 6. Okay, so let A and B be a set of outcomes less than 3, given as follows. So that's what we are given in this particular illustration. So A, there is 0, 1 and 2. So the cardinality of set A is 3. So remember, if you had watched my video on sets and the sets theory, I did mention that when you hear the term cardinality, it simply means the number of elements in a set, and the set is denoted or represented by curly brackets. So elements in a set, like in this case set A, we have them in the curly brackets. We have 0, 1 and 2. Then set B has a cardinality of 2 because there are 2 elements there. There is 1 and 2. What are we required in this particular case? The task is asking us to find out, are the 2 sets A and B events? That's a question we have to answer. So how do you go about this? Okay, so are the 2 sets events? So definitely when you look at set A, 0 is not one of the elements in the sample space. So it's not possible to have a set of that nature. So meaning that set A is not an event. But when you look at B, there is 1 identifiable in the sample space, also 2 identifiable in the sample space. So there is a possibility of having that in this part. So we can say that B is an event whilst A is not an event. Okay, so now we also need to look at the types of events. What type of events do we have? The events can be categorized into the following. One, there are those events which we call mutually exclusive events. Mutually exclusive events, meaning that when an event, if you have two events, event 1 and event 2, and said to be mutually exclusive, it means that if event 1 occurs, then event 2 can never occur. Or event 2 occurs, then event 1 can never occur. If such are events that you are facing, then the two events are said to be mutually exclusive. Okay? Another example in real life which you can say are mutually exclusive is when it comes to elections. Okay? Maybe you are electing a president. Okay? So once a president has been elected, you cannot have another president. So even if there were a number of candidates vying for the same position, once elected, then there can never be another president at the same time. So these kind of events are mutually exclusive. The other one is independent events. Independent events. Okay, we say events are independent if the outcome of one event is not dependent on the outcome of the previous occurring event. Then we say these events are mutual, they are independent events. These events are independent when the occurrence of an event is not dictated to or is not dependent upon the occurrence of another event. Then we say these events are independent. We also have the third conditional events. We have the conditional events. Conditional events are those events where the outcome of an event is dependent on the outcome of the prior event. Then we can say that those events are, that event is conditional because it conditioned upon the occurrence of a certain event or non-occurrence of a certain event. Okay, so those are the types of events you are likely to face in probability. Let me talk about the theoretical and empirical probability. Okay, theoretical and empirical probability. So for theoretical probability, this is where a probability calculated without the experiment performed. Theoretical. So a probability is calculated without an experiment or repetition being carried out. So this is known as a theoretical probability. Okay. We also have the empirical probability. On the other hand, the probability calculated is a result of an experiment having been performed a number of times. So that is known as empirical probability. This one is also known by another name as relative frequency probability or subjective probability. So that's what you should also know. Okay. So just to recap on the set theory, okay, we learned that a mathematical set can be described as a collection of distinct objects, normally referred to as the elements or members. Okay, so that's what we call a set. Okay, and these sets are denoted or represented by in form of capital letters. So to identify a particular set, or sets are distinguished by giving them capital letters, whereas elements could be in form of small letters. So that's the standard. Okay, so the sets are identified by uppercase letters, and then the elements are identified by lowercase letters. We also need to look at operations on sets. Operations on sets. It's important to understand what type of operations are available on sets. I have a number of them listed for you. First one, we're talking about set union. Okay, set union. Okay, in this particular case, okay, the union of two sets, let's say set A and B, is written as A union B in this symbol which you are seeing here. Okay, meaning that you are going to have elements in set A combined with elements in set B to form another set which is a union set. We also have intersection set. Okay, now if you have two sets A and B, the intersection set, okay, is made up of elements which are found in both A and B. That is what is known as an intersection set. So they are found in both set A and set B. What is also important is to understand set enumeration. Okay, set enumeration. This is the consideration of sets in terms of number of elements. Okay, so the counting the elements in a set. Okay, under various conditionalities. Okay, for instance, union set or intersection set. Okay. Okay, that's what is known. So the identification of elements in these areas is what is termed as set enumeration. Okay, so we did mention in this particular case that there is the term known as cardinality of a set, which refers to the count of elements or count of members in a particular set. So look at the solution for the general enumeration problem. Okay, there could be a problem with the enumeration, but the solution is as follows. We normally follow a structured approach to resolve these particular problems, which is in the manner of one. First of all, make sure that you identify the attribute set. Okay, identify the attribute set, meaning that you need to know the characteristics that you are fetching, okay? The attributes, the features you are looking for to form a set. So that's the first part. Identify the attribute set. Then number two, draw an outline Venn diagram, okay? So the outline Venn diagram just assists you to indicate the periphery or the border or the limits or the boundaries which encapsulates these particular elements of interest. So this Venn diagram will also capture what we call the sample space. Okay, the sample space. The Venn diagram is also known as the Euler diagram. Okay, after the name Euler, the one who Euler diagram. Okay, so that's what we have. Or a Venn diagram can be also referred to as the universal set. Okay, Euler diagram. That's why sometimes the Venn diagram or sample is given the letter E, Euler diagram, or is given the letter U to indicate that it's a universal set. And then third, is you need to use the information given to fill in as much of the diagram as possible. So once you are given the information, now with this Venn diagram in place, you can now reason to fill up the information that you are given. And then finally, evaluate the number of elements in any unknown area. Okay, so that's how we deal with solving the general enumeration problem. We also take a peek on set builder notation, set notation. So set notation can be useful when considering a number of different events that may occur in a given experiment. Okay. For instance, if we consider one number selected from a set of numbers 1 through to 9 in this particular set, considering this set as a universal set, Okay, it clearly contains a number of subsets which you can draw from it. For instance, the subset of odd numbers. So you go to the universal set in this case, which has 1, 2, 3, 4, 5, 6, 7, 8, 9. So you identify those which are odd numbers. They are in the form of 1, 3, 5, 7, and 9. Okay, that is a subset of the universal set. So odd numbers. Then the subset of multiples of 3. So those numbers which are divisible by 3, you have 3 itself, there is 6, and there is 9. So that's the subset of multiples of 3 from the same universal set. Okay. Now, I've indicated that if an A is an event of a selected number being odd, okay, like we have 1, 3, 5, 7, and 9, and B is an event of a number selected being a multiple of 3, okay, we can show this in form of a Venn diagram. Okay, you can show this in form of a Venn diagram. So let me look at how we can show this in form of a Venn diagram. Okay, we can show this in form of a Venn diagram. Okay, so let me look at that. Okay, so what we have is then we have the universal set made up of 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the universal set. That is the universal set. Okay, and then the set of odd numbers. Okay, odd numbers. You can say this one is the universal set. Okay, then this one we're saying odd numbers. Odd numbers. So we use curly brackets, that's a standard. So the odd numbers we're saying is 1, 3, 5, 7, and 9. That is a set of odd numbers. Okay. Then the other one we have is a set of multiples of 3. Set of multiples of 3. Okay. Set of multiples of 3. Multiples of 3. In this case, okay, multiples of 3, we have 3 itself followed by 6 and then 9. So that's how it is. Okay, so now what are we told? Okay, so we are told that we can show this the outcome as a Venn diagram. We can show the outcome as a Venn diagram. So now in universal set we have 1, 2, 3, 4 through to 9. Then what belongs to odd number set is 1, 3, 5, 7, 9. What belongs to multiples of 3 is 3, 6, 9. Now we can see that between set of odd numbers and set of multiples of 3, there are common elements. There is 3, also 3 there, and there is 9, there is also 9 there. So meaning these 3 are the ones that form the intersection set. So these 2 rather, are the ones which make the intersection set. So if we want to look at the intersection set, Okay, it will be in form of we have 3 and 6 and 9 rather, and 9. So those are the ones that will be represented in form of the intersection region of a Venn diagram. Okay, the intersection region of a Venn diagram. So if we look at this one, if this is a Venn diagram, then what we are going to see is that the whole collection of elements is 1 through to 9, and then if event 1 is a set A of odd numbers, then you are going to have under event 1, you are going to have 1, 3, 5, 7, and 9. Whereas when it comes to event 2 being the multiples of 3, then you are going to have 3, 6, and 9. So in this intersection region, there will form the 3 common ones to the both sets, that is 3 and 9. So that's how we normally prepare the Venn diagram. That's how we can prepare the Venn diagram in this particular case. Okay, so that is what we have. So find the following probabilities. Now if you are taught to find the following probability, first one is probability of odd numbers. In this particular case, how do you find the probability of odd numbers? So that's what we are going to do. Let me look at that. Okay, probability of odd numbers. Probability, if the probability, say odd numbers, okay, will be equal to, okay, so the probability success, the number of success items, so success or favorable outcomes divided by sample space, which is given as S. Okay, favorable outcomes over sample space. Okay, so favorable outcome over sample space. So in this particular case, we can say, what is the number of favorable outcomes? So you come here, we counted odd numbers. How many? If you look at the cardinality of this, it's 1, 2, 3, 4, 5. Okay, the sample space, the cardinality is 1, 2, 3, up to 9. So meaning that how many items are in favor of what we are looking for? There are 5. How many are possible number of items? That's your invested. There are 9. So when you look at this calculation, in our case, we are saying number of favorable outcomes is 5 divided by possible outcome, which is 9. So that will be the probability. That will be the probability. So if I use the calculator, you're going to find the probability will be 5 divided by 9. 5 divided by 9, which is going to give you 0.555. So in this particular case, the probability will be equal to 0.555. That's the probability. Okay, that is the probability of odd numbers. Now we look at the other one. We are told find the probability of multiples of 3. Find the probability of multiples of 3. Again, we come here. Okay, this was number 1. We may number them. This was number 1. Okay. Okay, we come to number 2. For number 2, we are looking at the probability of what? Of multiples of 3. Probability of multiples of 3. That's what we are looking for. So what is it? We look at the cardinality of multiples of 3 set. Look at the cardinality of the multiples of 3 set. There are how many items? There are 3. 3, 6, and 9. Out of the possible, 9 in the universal set. So in this particular case, we are going to say the probability is the favorable outcomes is 3 divided by sample space is 9, which is simply 1/3. So meaning, when you look at that, our probability will be equal to, so go to the calculator, which is 3 divided by 9, okay, which is 0.333. Okay, so the probability can be stated as a decimal, like 0.555, or as a fraction. Okay, as a fraction, like 5/9 or 3/9. It can also be stated as a percentage. Okay, you multiply this one by 100. If you want to express this one as a percentage, you multiply this one by 100, then it will be 55.55%. Okay, 55.55%. If you multiply this one and find out you want to get it expressed as a percentage, you multiply this one also by 100. So you can have 0.333 multiplied by 100. Multiplied by 100. Okay, then you are going to have I think 3.3%. 3.33%. Okay, so that's what you should know. Equally here, you have to multiply by 100. You can express it as a percentage. Multiply 0.555 times 100. You are going to get this particular answer. Okay, so normally you don't show like all of them, just understand normally people want to use a decimal form, so you just pick one. It's still acceptable. Okay, still acceptable. Let's continue. We look at the third one. So probability of odd numbers and multiples of 3. Probability of odd numbers and multiples of 3. Okay, so we are looking at another calculation that we have to do. Okay, that is number 3. Okay, number 3. So which is item number 3. Probability of odd and multiples of 3. Odd and multiples of 3. Okay, multiples of 3. If I may use this shortcut, what is the probability? Probability of odd and multiples of 3. What is the probability? Okay, so what we normally do, if we are going to, I'm going to discuss this later. When you look at the rules of probability, when you have the term and used, it means that you have to multiply the two probabilities. When you have the term and, in this case, you have to multiply the two probabilities, meaning that in this case you have probability O, which is probability of odd numbers. Okay, probability of odd numbers multiplied by probability of multiples of 3. Multiples of 3. So what do you get in this particular case? What you are going to get is are going to have equal to probability of odd number is 5 out of 9, then multiplied by probability of multiples of 3, which is 3 out of 9. Okay, so that's what you have. that is what you are supposed to have. In that particular case, you are going to have probability equal to, that's like saying 0.555, 0.555 times 0.333. So times 0.555. So whatever it goes, to give you roughly, that is, let me get it back, give you 0.185185. Okay, 0.185185, not mistaken, 5185. Okay, let me just counter check. Okay, 0.185185. That will be the probability. Okay, that will be the probability. Okay, so you can see all these probabilities, if you look at the decimal form, they are in between 0 and 1, the chance, okay, that this particular outcome comes to pass. Okay, that's what we are seeing in this particular case. What is the next one? The next one is probability that the outcome is not a multiple of 3. Outcome is not a multiple of 3. So what is this? So you have to find the cardinality of that. So we get back to this particular arrangement. Okay, it's not a multiple of 3. Okay, so meaning that if you look at these two sets, okay, in our analysis, okay, multiple of 3, not a multiple of 3, it means that the rest, okay, the rest means that you are talking about 1, 2, 4, we have, let me just put it down here so that it's easier for us to relate it to it. Okay, not multiple of 3. Okay, so what type of set are we going to have in this particular case? We have 1, we have 2, we have 4, we have 5, we have 7, we have 8. Okay, so this is what we have. These are not multiples of 3. How many are they? They are 1, 2, 3, 4, 5, 6. So meaning, so the cardinality of this set is 6 out of the cardinality of universal set, which is 9. So the probability of not multiples of 3 will be 6 out of 9. So we come here, 6 out of 9. We come here. Okay, maybe we look at this new slide. We can start with a new slide. Okay, okay, there we are. So we are looking at the probability of not multiple of 3. Okay, so probability of not multiple of 3. So that's what we have. Not multiple of 3. Okay, not multiple of 3. So we have that. So what are we saying? What are the favorable outcomes? In this particular case, the count, the cardinality is, as we have said, 6. Not multiple of 3 has 6 elements. Okay, 6 elements. So that's what we have. So it is in this particular case, we are saying 6 out of the possible 9 in the universal set. So that's what we have. So again, if you want to calculate this particular probability and express it as a decimal form, you are going to have maybe use the calculator again. So it is 6 divided by 9. 6 divided by 9. What you get is that figure 0.6666, that kind of thing. That's about, or 66.67%, as I've already explained. So that is the probability of not being a multiple of 3, not a multiple of 3. Okay, so that's what it is. So that's how we end up calculating this probability multiple of 3. Okay, multiple of 3. So that's how it is. Okay, so what is the next one? The next one is probability multiple of 3 or odd number. Okay, multiple of 3 or odd number. Just like before, as I've already cautioned you, when we look at later on the rules of probabilities, when you have or the statement is expressing an option or a choice. Here it is or, means that it's an option or a choice. Okay, then we add the probability of them. The probability involved, we add the probability, just like for where it says and, this is an intersection, union set, we multiply the probability. So whenever in the mathematical statement dealing with probability, you have an event followed by another event, means that that event and another event, you multiply the probability. So in this case, you have or, means that if a certain event or another event, okay, you add the probability. So here we are going to add the probability of multiples of 3 to the probability of multiple of to the probability of odd numbers. Probability of having odd numbers plus the probability of having multiple of 3. So I think we have already calculated that. Probability of odd number is 0.555. Probability of having multiple 3 is 0.333. So when you add this, okay, you are going to have, in this particular case, as I've said, probability of odd number and rather it says or multiples of 3. Of 3. So that's how it is stated. So what is this? We are going to look at probability odd number, and just copy this, pin it here, and actually paste it. Probability that, then plus, okay, plus. Again, I put another one here. Put here this one, probability multiples of 3. Multiples of 3, like that. So multiples of 3. Okay. So now what we have in this particular case, since I've already told you that you add the probabilities, and we know the probability already, the probability of odd number is 0.5555 plus probability of multiples of 3, probability of multiples is 0.3333. Okay, so if you look at that, it will give you the probability being, when you add the two, to be 0.8888. Okay, so that is the probability. Okay, that is the probability. So that's how we handle these particular probabilities. Okay, that's how we handle these particular probabilities. Then we also have another example. Okay, this example has to do with one element is randomly selected from a universal set of 20 elements, and then you are told set A and set B are subsets of universal set, and the number of items in set A is 15, number of items in B is 10, and the cardinality of the A intersection B is 7. So that is the statement given before us. Now you are asked, what if the probability of A is the probability of the selected elements belonging to set A? Find the following probabilities. Okay, find the following probabilities. So what do we do in this particular case? Okay, we are faced with this particular situation. Okay, so here is a question of us determining the cardinality. Okay, us determining the cardinality. So we are told that the number of items in A is 15. Out of the possible outcome in the universal set 20. So it's very easy to calculate. In this particular case, we can just say, okay, fine, we have equal to 15 divided by 20, okay, which is equal to 0.75. Okay, that is the probability. Okay, there are 15 items in state A, and out of the possible 20 elements in the universal set, so that is 15 over 20, which is 0.75. We come to this one. Okay, we look at that one. We are told probability of A intersection B. Okay, probability of A intersection B. So the cardinality of A intersection B, we are told, is 7. Okay, out of the possible 20. So it's easy again. So the favorable outcome is 7 divided by possible 20 outcome. Okay, so what do we have? Okay, the probability will be calculated as, we look at that one to be 7 divided by 20, given as 0.35. 0.35. So that's what we have. We come to this one. Probability is supposed to be B complement. Okay, B complement. Okay, B complement. Okay, probability B complement in that particular case. Okay, so what is outside B? What is outside B? So if what is in B is 10, what is in B is 10, meaning that we have captured 10 items out of the 20 elements. Okay, 10 items out of the 20 elements. Then what is outside should be the remainder, which is how many are those? That should be 10. Okay, so if in B there are 10, then outside we have 10. Okay, so meaning we are going to have B complement. This means that elements outside the set B, elements outside the set B. Here we are told the set B has a number of elements 10, and the total in the universal set is 20. If you have 10 belong to B, then the outside B they are 10. So we are going to have 10 divided by 20, which is going to be equal to half, 0.5. Okay, 0.5. Okay, so what is what of probability of A union B? Probability of A union B. Okay, so A union B, you have 15 under A, we have 10 under B, and 7 of them are common between A and B. Okay, so meaning that if you look at 10 here, which is covered 7 here, meaning that what is remaining out of that is only you're looking at 8. okay, 8. So you have means that you have 10 under B with 8 which are belonging to B, that will give you 10 plus 8. It's not yet 20. That means the outside there are 2, okay, outside there are 2. So that's what you're going to see, okay, outside there are 2. So A union B means that you have 8 in A and you have 10 in B. That's 18, okay, that is 18. How do I calculate that one? Let me demonstrate this one. Okay, if B, if I use this part, if B has 10, B has 10, okay, B has 10, and then what of A? A should have 8. Okay, A should have 8. Why? Because in A we have 7 which are also part of B. So those which are purely in A are 8. Okay, so because in this particular regard we are told the number of elements in set A is 15. So this 15 you are seeing here, 15 that you are seeing, has communalities which we will remove, that is 7, okay, leaving you with 8, okay. So those which are not part of B but they are part of A are 8. Those which are in A but also part of B are 7, okay. So that's the arrangement here. So meaning when you look at B union A, you are going to look at 10 plus 8. Okay, 10 plus 8, which is 18. Okay, meaning that what is now outside A, outside which is B union A complement, which is outside the union of A and B, is only 2 to make the 20. So that's how it is done. So in this particular case, when you come to this fourth item, probability of A union B, we are saying 10 plus 8 after we have removed the commonality of 7. So it means there is 8 purely for A and the 10, which also includes with the 7 which are part of A, to make 7 plus 8, 15. Okay, so A union B is 10 plus 8, which is 18. Okay, probability of A union B is going to be 18 out of the possible 20. Okay, out of the possible 20. So that will give us the probability of, you can look at that one, calculate again. You have 18 divided by 20. Okay, that would be 0.9. Okay, that is the probability. Okay, so such is the probability. Okay, then we move on to look at the next one. Okay, I talked about Venn diagram. What is important is to look at also these other points. Okay, we say if the sum of possible outcomes of an experiment is represented by points in a space of countable dimensions known as sample space, then each point can be assigned a probability. That's what we have been seeing in what we have been dealing with. Okay, the other point which is trying to augment what we have seen is that the sum of this probability in sample space will always be equal to 1. Okay, so it will always be equal to 1. Okay, that is also what is supposed to be looked at. So let's look at how do we exploit or explore this particular information or this particular ideas. Okay, let's look at how these ideas can be or arrived at. Okay, so we are saying probability of sample space, if you have events E1 and events E2, then it simply means when you look at the sum of events 1 and events 2, that will be the sample space, because those are the total possible outcomes. Okay, so the what we have seen is that we are saying the sum of possible outcomes will always equal to 1. Okay, 1 is equal to probability of event 1 plus probability of event 2. That's what it means there. Okay, so probability sample space is made up of all the events 1 and the events 2, or you can simply say both, hence the universal set. Okay, so probability sample space is probability event 1 union probability event 2. Okay, so the union set of these events, if these are the two events, that will give you probability 1. Okay, probability 1. Probability event 1 and event 2 is simply the multiplication of events. So that's what we have applied when it came to answering this particular question, where we have probability A intersection B. So we had to if you want, you can actually calculate this one by looking at probability A multiplied by probability B. Okay, so that's what it is, probability A plus probability B. Okay, so that's what you can do. Then also when you look at this other one, you're told this implies the intersection of event 1 and event 2. So when you are multiplying, you remember I've said when in probability you use and, you multiply. Whenever there is and, you multiply. Whenever there is or, you add. Okay, that's the idea. So you can see that probability event 1 and probability event 2 simply means probability event 1 times probability event 2. Okay, so it means probability event 1 intersection probability event 2. That's what it is. Now, the other thing that you need to understand under probability is that if set contains no elements in it, that set is known as a null set, represented by the Greek alphabet letter of phi, such that if event 1 and event 2 is an empty set, then event 1 and event 2 is equal to phi, or probability event 1 followed by event 2 is equal to 0, because when you multiply this, it will still be 0. 0 times 0 is 0. Okay, so that's what we have there. Okay, so following off from those statements, we can sum up to say probability sample space is always equal to 1, and probability sample space is equal to the probability of individual probability of events. So probability event 1 plus probability event 2. Then it follows that if you have probability event 1 plus probability event 2 equal to 1, then probability event 1 is equal to 1 minus probability equal probability event 2. Okay, so that's what it is. Okay, for instance, if you are talking about this event, let's look at this one. We calculated here the events. Okay, we calculated the events. Okay, this one. So there are only two events. Okay, there are only two events. There is let me use this one. Okay. Okay, for instance, this one. Okay, we have event odd numbers is 0.55. Event even numbers, if we can find even numbers, okay, it will be let me just calculate. Prevent even numbers. Even numbers, there are 1, that's 2, 4, 6, 8. Okay, 2, 4, 6, 8. So when you look at the cardinality of even numbers, is equal to, open this one, that is 2, 4, 6, 8. Okay, that's what we have. So mean that it has 4, 2, 4, 6, 8. These are even numbers. So if that is the universal set, either you have odd numbers or even numbers, then let's see what is the probability of even numbers. What is the probability of even numbers? If I may work it out just here, even numbers means that is 4 divided by 9. Okay, probability even numbers, probability even numbers is equal to even numbers. There are 4. 1, 2, 3, 4. Total outcome is 9. So what is this going to give us? Look at that. What is it going to give us? 4 divided by 9. 4 divided by 9 gives you 0.444. 0.4444. Okay, so probability of so we look at then means that the whole sample space in this particular case. Okay, if I may look at that, let me cut this one, take it somewhere. I just want to calculate here. Okay, so we go here. Okay, let's look at this. So we push it there. Okay. Okay. So this is what we have calculated. Probability of even number is that. Okay. Now, I want to prove a point. I want to know the sample space is made up of even number sample space. Sample space probability. Sample space is equal to event odd numbers plus event even numbers. Okay. Okay. So now that is the what is in the set. There, if you combine them, there we find odd numbers and even numbers. Okay. Now, if you look at this, okay, what is the probability of odd numbers? We have found is 0.555. Okay, and what is the probability of odd number or even numbers? So we add is 0.444. Okay, if we add this, you are going to find it is going to be equal to 0.9999. Okay, so basically when you round it up, it will give you equal to 1. Okay, so meaning the probability sample space is always equal to 1. Okay, probability sample space is always equal to 1, such that if you want to find out the probability of even number, given that you know the probability of odd number, then you are going to just say, okay, fine, since 1 is equal to probability odd number plus probability even number. Okay, and you know that in this particular case is saying 1, because you know it, 1 is equal to, let's say you know this is 0.555. and you don't know this other one, probability even number, then you just make probability even number the subject of the formula. Probability even number will be equal to 1 minus 0.555. So definitely you're going to get the other one 0.444. Okay, so that's how it is done. So that's the logic behind that. Okay, that's the logic behind what we are trying to calculate here. Okay, hence we talk about the complementarity of event. Okay, so hence probability event E1 complement is equal to 1 minus probability E1. Okay, probability of event 2 complement is 1 minus probability E2. Okay, so that's what is being done there. So those are the coming from the set builder notation, and this forms part of the first part of the probability, or probability part 1. We are going to develop these concepts and start looking at more challenging problems relating to probability. Thank you for listening to my YouTube channel. I would like you to please subscribe to my channel and like my videos. And more importantly, I would like to get feedback on what you want to be covered. Thank you for listening.